Hello and welcome to the next edition of the Hewlett-Packard Enterprise Business Transformation Interview Series. I'm Dana Gardner, Principal Analyst at InterArbor Solutions, your host and moderator for this ongoing discussion on IT transformation and how it's making an impact on people's lives. Our next top innovator case study discussion explores the impact and experience of using Internet of Things technologies together with big data analytics to provide better control and management over a burgeoning transportation agency in New Zealand. To hear more about how fast big data supports rapidly evolving demand for different types of sensor outputs and massive information inputs, please join me in welcoming our guest, Roger Jones, CTO for Auckland Transport in Auckland, New Zealand. Welcome, Roger. Tell me a little bit more about your organization, its scope, its size, and what you're doing for the people in Auckland.
Okay, so Auckland Transport was formed 5 years ago. We just celebrated our 5th birthday from an amalgamation of 6 regional councils, and all the transport functions out of those were merged along with the city functions into a super city concept, of which transport was pulled out and set up as a council-controlled organisation. But it's a semi-government organisation as well. So we get funded by the government and we get funded by the ratepayer, and then we get our own income as well. So we have multiple stakeholders. We're run by a board, an independent board, as a commercial company. We look after everything to do with transport in the city. So all the roads, everything on the roads, light poles, rubbish bins, the maintenance of the roads and the footpaths and the grass berms, building roads, and then we do public transport. So we run and operate the ferries, buses and trains, and we also promote and manage cycling across the city, walking activities, commercial vehicle planning, how they operate across the ports and carry their cargoes, and also carpooling schemes.
Well, that's a very large, broad set of services and activities. Of course, a lot of people in IT are worried about keeping the trains running on time. As an analogy, you're literally doing that.
Yep, so we've got a lot of real-time systems and trains. We've just brought in a whole new electric train fleet. So all of the technology that goes with that has to be worked through, and that's the real-time systems on the platforms, right through to how we put Wi-Fi onto those trains and get data off those trains. So all of those trains have got CCTV cameras on them for safety, how you get all that information off and analyse it. There's about a terabyte of data come off all of those trains every month. It's a lot of data to go through and work out what you need to keep and what you don't.
And of course, you can't manage and organize things unless you can measure and keep track of them. In addition to that terabyte you talked about with trains, what's the size of the data, and not just data as we understand it, unstructured data, but content that you're dealing with across all of these other activities?
So our traditional data warehouse is about 3 terabytes in round numbers, and on the CCTV we take about a petabyte of data a week, and that's what we're analysing. That's from about 1,800 cameras that are out in the streets. They're in a variety of places, mostly on intersections, and they're doing a number of functions. So they're counting vehicles, and under the new world what we want to do is count pedestrians, count cyclists, have the cyclists activate the traffic lights, because from a cycle safety perspective, the new carbon fibre bikes don't activate the magnetic loops in the roads, and so that's a bone of contention that they can't get the lights to change. So we'll change all that using CCTV analytics and promote that. But we'll also be able to count vehicles that turn right, where they go in the city through number plate recognition. By storing that, when a vehicle comes into the city, we'll be able to see if they travel through the city, average length of stay. And then what we're working on currently is putting in a new parking system where we will collect all the data about the occupancy of parking spaces and be able to work out in real time the probability of getting a car park in a certain street at a certain time, and be able to make that available to the customer, and especially the tradesmen who need to be able to park to do their business.
Very interesting. So we've heard a lot about smart cities and bringing intelligence to bear on some of these problems and issues. Sounds like you're really doing that. In order for you to fulfill that mission, what was lacking in your IT infrastructure? What did you need to change, either in architecture or an ability to scale or adapt to these different types of inputs?
So the key driver was having merged 5 councils. We had 5 different CCTV systems, for instance. They were watched by people manually, and if you think about 1,800 cameras being monitored by maybe 3 staff at a time, it's very obvious that they can't see actually what's happening in real time, and most of the public safety events were being missed. The cameras were being used for reactive investigation rather than active management of a problem at this point in time. So that drove us into what do we do around CCTV and the analytics, and how we automate that and make it easy for operators to be presented with in real time, here's a situation you need to manage now, and be able to be proactive. And that was the key driver. And then when we looked at that, and then you looked at all the other sensor data around the city, it's how do you put that all together and process it in real time and be able to make it available again, both to ourselves, to the police, the emergency services, and to other third-party application developers who can build their own applications using that data, but it's no value if it's historic.
Mm-hmm. So a proverbial Tower of Babel, how did you solve this problem in order to bring those analytics to the people who can then make good use of it and in a time frame where it can be actionable?
So we did a scan, as most IT shops would, around what could and couldn't be done. There's a mix of technologies out there, lots and lots of technologies. And one of the considerations we took was which partner should we go with? Which one was going to give us a longevity of product and association? Because you could buy a product today, and in the changing world of IT, it's out of business, or it's been brought over, or it's changed in 3 years' time. So we needed a brand that was going to be in there for the long haul. Part of that was could the brand, and there's multiple big brands out there, did they have the breadth of the tool sets that we were looking for, both from a hardware perspective, managing the hardware, and the application perspective. And that's where we selected HP, taking all of those factors into account.
Mm-hmm. So tell us a bit about what you're doing with data. On the front end, you're using a high-speed approach. Perhaps in a warehouse, you're using something that will scale and allow for analytics to take part more quickly. So tell us a little bit about the tiering and the network and what you've been able to do with that.
So what we've done is taken a tiered approach. For instance, the analytics on the CCTV comes in and gets processed by the idle engine. That strips most of it out. We integrate that into an incident management system, which is also running on the idle engine. And then we take the statistics and the pieces that we want to keep, and we're storing that in Vertica. So we're doing that, and the parking system will go into Vertica because it's real-time, near real-time processing of significant volumes. The traditional data warehouse, which was a SQL data warehouse, is still very valid today, and it'll be valid tomorrow. That's where we're putting a lot of the corporate information and tying a lot of the statistical information together so that we've got all the historic information around the real time, which was always in an old data warehouse. We tie that together with our financials. A lot of smaller changing data sets are held in that data warehouse, and then we combine that information with the stuff in the Verticas and the APS appliances to get us an integrated reporting out the front end in real time. We're making a lot of that information available through an API manager, so that whatever we do internally is just a service that we can pick up and reuse or make available to whoever we want to make it available to. It's not all public, but some of it is to our other partners and our stakeholders, so it's a platform that can manage that.
So you mentioned that APS appliance, a Microsoft and HP collaboration. That's to help you with that real-time streaming, high-velocity, high-volume data. And then you've got your warehouse. Where are these being run? Do you have a private cloud? Do you have managed hosting, public cloud? Where are the workloads actually being supported?
So the key workloads around the CCTV, the idle engine and Vertica are all running on HP kit on our premises, but managed by HP Critical Watch. So that's an HP, almost an end-to-end service, but it just happens to be on our facilities. The rest is, again, on our facilities. The problem in New Zealand is there's not many private clouds that can be used by government agencies, and we can't offshore it because of latency issues and the cost of shipping data to and from the cloud via the ISPs who know how to charge on international bandwidth.
Right, of course. Okay, great. So now that you've put your large set of services together, what are some of the paybacks you've been able to get? How do you get a return on investment, which must be pretty sizable to get this infrastructure in place? What are you able to bring back to the public service benefits by having this intelligence, by being able to react in real time?
So there's two bits to this. The traditional data warehouse was bottlenecked. So if you take from an internal business perspective, the processing out of our integrated fares system, which is a batch-driven system, the processing window each night is around about 4.5 hours. To process the batch file was just over that. So we're actually running into not getting the batch file processed till about 6 a.m. At that point in time, the service operators, the bus operators, the ferry operators have already started work for the day. So they weren't getting yesterday's information in time to analyse what to do today. So using the APS compliance, we've cut that down to that process now takes about 2 hours end to end. So we got a huge performance increase. That means that by the time the operators come in, they have got yesterday's information and they can make the right business decisions. On the public front, I put it back to the customer experience. If you go into a car park and have an incident with somebody in the car park, your expectation is that somebody will be monitoring that and somebody will come to your help. Under the old system, that was not the case. It would be pure coincidence if that happened. Under the new scenario, from a public perception, that will be alerted, something will happen and someone will come to you. So the public safety is a huge step increase. Now that has no financial ROI directly for us. It has across the medical spectrum and the broader community spectrum, but for us as a transport agency, it has no true ROI except for customer expectations and perceptions.
Well, as taxpayers, having expectations met, I think, is probably a very strong attribute for you. When we look at your architecture, it strikes me that this is probably something more people will be looking to do because of this Internet of Things trend, where more sensors are picking up more data. It's data that's coming in maybe the form of a video feed across many different domains or modes. It needs to be dealt with rapidly. What do you see from your experience that might benefit others as they consider how to deal with this Internet of Things architectural challenge?
So we had some key learnings from this, and it's a very good point. The Internet of Things is all about connecting end devices. When we went from the old CCTV systems to the new one, we didn't actually understand that some of that data was being aggregated and lost forever at the front end. And what was being received at the back end was only a snippet. When you start streaming data in real time at the volumes, it impacts your data networks. So suddenly your data networks become swamped or potentially swamped with large volumes of data. That then drove us to thinking about how do you put that through a firewall. And the reality is you can't. The firewalls aren't built to handle it. We run F5s, and we looked at that, and they would not have run the volume of CCTV through that. So then you start driving into other things about how do you secure your data, how do you secure the endpoints, and tools like Seam, locking down your networks so that you understand what's connected or what's changed at the connection end, what's changing in the traffic patterns on your network, become essential to an organisation like us, because there's no way we can secure all the endpoints. You know, a set of traffic lights has a full data connection at the end. If someone opens the cabinet and plugs in a PC, how do you know that they've done that? You know, and that's what we've got to protect against. And the only way to do that is to know that something abnormal's there, it's not the normal traffic coming from that area of the network and then red flagging it and blocking it off. That's where we're heading, because that's the only way we can see the Internet of Things working from a security perspective.
Mm-hmm. Now, Roger, when you put this amount of data to work, when you've solved some of those networking issues and you have this growing database and historical record of what takes place, that can also be very valuable. And so do you expect that you'll be analyzing this data over historical time period, looking for trends, and perhaps applying that to feedback loops where you can refine and find productivity benefits? How does this, over time, grow in value for you as a public service organization?
So the first real payback for us has been the integrated ticketing system. So we run a tag-on, tag-off electronic system. For the first time, we understand where people are travelling to and from, the times of day they're travelling, and the demographics, to a certain extent, of those travellers. We know if they're a child, we know if they're a pensioner, or they're a student, or just a normal adult type user. For the first time, we're actually understanding not only just where people get on, but where they get off and the time. So you take that, we can now start to tailor our messaging. Special event transport, for instance, if we have a special event, a rugby game, that may only be of interest to a certain segment of the population, or a pop concert. So where do we put our advertising? Where do we put our messaging about the transport options for that? We can now tailor that to the stops where people are there at the right time of day. We could never do that before. But from a planning perspective, we now have a view of who travels across town, who travels in and out of the city, how often, how frequent, times of the day. We've never ever had that. The planners have never had that. When we get the parking information coming in about the parking occupancy, that's a new set of data they've never had. So this is very much about the planners having reliable information. And if we go for the license plate reading, we'll be able to see where trucks come into the city and where they go through. So one of our big issues we've got at the moment is we've got a link route that goes into the port for the trucks. It's motorway. How many of the trucks use that versus how many trucks take the shortcut straight through the middle of the city? We don't know that, and we can do ad hoc surveys, but we'll have that in real time constantly forever, and the planners can then use that when they're planning the heavy transport options.
Very interesting. Well, I'm afraid we'll have to leave it there. We've been learning about how big data and modern networks and a tiered architectural approach has helped a transportation agency in New Zealand improve its public safety, its reaction to traffic and other congestion issues, and also set in place a historic record to help it improve its overall transportation capabilities. So I'd like to thank our guest. We've been joined by Roger Jones, CTO for Auckland Transportation in Auckland, New Zealand. Thank you, Roger.
Thanks very much.
And thank you to our audience for joining us for this Hewlett-Packard Enterprise Transformation and Innovation interview. I'm Dana Gardner, Principal Analyst at Inter Arbor Solutions, your host for this ongoing series of HPE-sponsored discussions. Thanks again for listening in. Come back next time.